In this video, we are going to discuss the question 1 of question paper 52 of 9701 chemistry, that is A levels chemistry of the examination series May-June 2025. But before we start, let me tell you that if you want an access to enough resources, all the required resources of IGCSE chemistry, then don't forget downloading our chemistry app from the chemscience.in, which the link is given in the description. So here is our question 1 of the question paper 52. So here its activated carbon is a form of carbon with the ability to absorb solutes from the solutions. Now the adsorption of ethane dioic acid molecules from its dilute acid solution onto the surface of activated carbon is studied in a series of experiments. Now before we begin the experiment, 500 centimeter cube of 0.139 moles per dm cube concentration of ethane dioic acid aqueous solution X is made. Now the activated carbon is placed in an oven at 120 degrees Celsius for 3 hours. Now whole the experimental procedure is given. You can pause the video and read all it, but let me just in brief tell you that prepare 100 centimeter cube of 0.00556 from the solution given, and this 50 centimeter cube of this solution is taken into conical flask and 0.50 gram of activated carbon is added to it, and the stopwatch is started, and then the adsorption is measured at regular interval of time. So here is the whole process, where sub question 1a is a solid ethane dioic acid has the formula given here, which is an hydrated compound. Now calculate the mass of this compound required to prepare 500 centimeter cube of 0.139 moles per dm cube solution X, that is ethane dioic acid solution X. Now here is the concentration given, here is the volume given, and we need to find out the mass. Now if we want to find out the mass, first of all we'll need to calculate the MR of ethane dioic acid of this formula. Now if you apply that, then we have 12 plus carbon 12, oxygen is 16, so 16 again plus 16 plus 1 for the COOH. Now that fully has to be multiplied by 2 plus 2 molecules of water, so 2 into 18. Now water is 18, we already know. If we total up this, we have the MR of 126 gram. Now this is the 126 MR. Now we know that the moles is equal to concentration into volume, but then moles is also equal to mass upon MR. Now if we want to find out the mass as a subject, MR will shift this side, so we can write mass is equal to concentration into volume into MR, and for that we can write the concentration, we know it is 0.139. So 0.139 into volume, that is 500 centimeter cube, divide by 1000 to change it into dm cube, which is equal to 0.500. So multiply by volume 0.500 into the MR, that is 126 relative molecular mass. So if we calculate all this, we get the mass of 8.76 to 3 significant figures. So the mass required is 8.76 gram. Yes, I hope the calculation is very clear. Now the mass of this ethane dioic calculated in A1 is placed in 100 centimeter cube beaker. Now we have already weighed this and taken into the empty beaker of 100 centimeter cube capacity. Now describe the steps taken to prepare 500 centimeter cube of this solution. Give the name and the capacity of any apparatus used. Now write your answers using a series of numbered steps. Now what are we going to do is we have already taken the mass. So what we can write in the first step is that add little water to the beaker containing the solid sorry, the spelling is wrong, containing the solid COOH, that is ethane dioic acid, hydrated molecules of that into the beaker. Okay, so what we are doing is adding a little water to the beaker which contains this solid and dissolve it. We can stir it to dissolve it. Yes, then transfer this solution, that is, this solution means what? The dissolved solution of ethane dioic acid into, now how much of this volume we need to prepare? 500 centimeter cube. So we'll transfer this solution into 500 centimeter cube of volumetric flask. Remember, we are using volumetric flask. Now what is volumetric flask? That's a flask which is used to prepare any standard solution. So after transferring this solution, transfer few washings of beaker also to the flask, that is volumetric flask. Now top, or you can say fill up, top up to the mark. Now each of the volumetric flask will have a particular mark, so top up to the mark with distilled water. Specify distilled water because to prepare any solution we use distilled water only. So top up to the mark with the distilled water, and then we can say shake well. Shake well is required because if we add water slowly from the top, then water will be on the top and the concentrated solution will be at the bottom. So necessary to shake well. So these are all the steps you will describe to make a standard solution with the help of volumetric flask. Now sub question B is, the ethane dioic acid is corrosive. Other than wearing eye protection and a lab coat, take one more safety precautions should be taken using this. Now we know that it is corrosive, so using gloves is also necessary, but then it is necessary to specify that chemically resistant gloves has to be used. So chemically resistant hand gloves or gloves should be used. Specify chemically resistant gloves. Yes. Suggest why the activated carbon is placed in the oven before use. Now all the water from carbon is evaporated before use from the carbon. So that is necessary, and that's why we are heating it into the oven for a very long time, so that all the water which is absorbed inside the carbon is also evaporated out. Now in the D, in step 1, solution X is diluted to the concentration of 0.00556 moles per dm cube. So this concentrated solution is diluted. Now here it says calculate the volume of the solution X needed to make 100 centimeter cube of this diluted concentration. So if we use a simple formula of C1 V1 equal to C2 V2, where the concentration and volume respectively are used, so we can say that the volume used of 0.139 solution we don't know. So V1 we have to calculate, the concentration is 0.139 equal to C2 V2. So what's the concentration and volume we are supposed to use is 0.00556 concentration, and its volume is 100 centimeter cube. Now if we use 100 centimeter cube directly without changing into dm cube, then obviously the V1 calculated will also be in centimeter cube, which we want. So V1 is equal to 0.00556 multiplied by 100 divide by 0.139. If this calculation is done, we get the volume as 4.00 centimeter cube. That's the volume we'll calculate after this calculation. Okay. E. Identify the most appropriate piece of apparatus to transfer 50 centimeter cube of diluted solution in step 2. Now if we want to transfer 50 centimeter cube and most appropriate, that is most accurate, then it's a burette which we can use to transfer 50 centimeter cube. Why not pipette? Pipette is also accurate, but then pipette we don't have it for 50 centimeter cube. Generally it is like 5, 10, 20 and 25 only. So either we can use 25 twice, but it's better to use burette directly, which will directly give us 50 centimeter cube of solution. Yes, now the sub question F is suggest a reason why the conical flask is shaken in step 4. Now let's understand what is step 4 here. Okay, step 4 is shake the flask immediately to remove immediately remove 5 centimeter cube sample from the flask. Determine the mass of the non-adsorbed in the sample using chromatography. Now here, before shaking, what have we done? We have added activated carbon to the flask and started the stopwatch. Now after adding carbon, if we are shaking well, then the only reason is that the solution to mix the solution thoroughly, or you can also say to mix it well, mix the solution well. That's also another language we can use. Yes, now G here is the results of the experiments are shown in table 1.1, and here is the whole table, where every 5 minutes we are taking out the solution and the non-absorbed we have calculated from 5 centimeter cube sample that is given here. Now mass of the ethane dioic compound adsorbed by activated carbon in 5 centimeter cube sample in milligraph. Now if we want to find out adsorbed, then what do we have to do is, like at 0 time this was the mass non-absorbed. Now if after 5 minutes the adsorbed is this, non-absorbed is this one, then the adsorbed is subtract this two. Next again we'll have to subtract this two, so we'll have to keep on subtracting the values from 2.5. Now if we keep on subtracting all these values 2.5, then we get the following readings, which I'll write it for you now. So now I have subtracted all the values from 2.50 and have mentioned all the values here. Yes, now the next sub question is plot a graph on the grid in figure 1.1 to show the relationship between the mass of ethane dioic acid adsorbed by the activated carbon in 5 centimeter cube sample and time t. Use a cross to plot each data point. Now what is here? The mass adsorbed by the carbon. So this is the column which we are going to use against the time given here. Draw a curved line of best fit. So let's see what's the graph here. Yes, here is the grid given. Let me minimize because it's not coming in the screen. So let me minimize and show you it. And also I'll plot the points after minimizing so that you can directly understand it. So now this is the grid I have minimized, and I have plotted the points according to like the ethane dioic acid mass adsorbed by the activated carbon in 5 centimeter cube sample against the time in minutes on x-axis. Now all the points are given here. Let's join it with a curved line on the grid. So here is the curved line joined. I can show you that the line is not totally perfect because it's on the screen, but yes, with the pencil and pen and paper you can definitely make a better line. And yes, I have also pointed out the anomalous point, circled the anomalous point. Now what is that? We can find out later on. Let's go ahead with the questions, sub questions next after the grid. Then the next sub question is identify the independent variable. Now what is the independent variable? Independent variable is the one factor which we change. Now what are we changing in this is the time. The time in minutes so that we can measure the mass adsorbed. So what are we changing is the time to measure the adsorbed mass. I'm just writing time in minutes, which is used to measure the mass of ethane dioic acid adsorbed. So here now fourth point is suggest one variable that needs to be controlled that is not stated in the experimental procedure. Obviously the most obvious factor that we have to keep same is temperature, because then the process is definitely affected, the rate of the process is definitely affected by the temperature. So temperature has to be kept constant to make the whole experiment fair. The fifth is circle the one point on the graph that you would consider to be the most anomalous. Now that we have already circled, explain the error in timings that may have led to this anomalous point. Now let's understand the reason for it. Now in the reason we can see that the mark should be somewhere here, but it's lower. So that shows that the mass of the adsorbed ethane dioic acid is lesser than the expected. Now that can happen only when we measure our experiment or we do the experiment earlier than the recorded time. So we can write the reason that the time for taking the reading is less than the recorded time or the actual time measured. Yeah, that can be the reason, because the mass of the ethane dioic acid adsorbed is less. Now here is sub question H, which says the experiment is repeated using different concentrations of ethane dioic acid prepared in step 1 and the results are shown in table 1.2. So here are the results where MI in milligram, ME in milligram, the subtraction of both, and the QE is milligram per gram, and it's given here. Yes, we can understand what is all this is. Mi is the initial mass of the ethane dioic acid in 5 centimeter cube, which we had earlier taken as 2.50. Me is the mass of non-adsorbed ethane dioic acid in final 5 centimeter cube. So if we want to find out QE, that is the mass of ethane dioic acid absorbed, we have to subtract these two, right? That's what we had done in our earlier part also. Okay, now a plot of Me upon QE against Me gives a line of best fit shown in figure 1.2. Use the figure to determine the gradient of the line of best fit. State the coordinates of both points used in your calculation, coordinates 1 and coordinates 2, and include units in your answer. Now let's have a look at the gradient. Yes, here is our gradient where here we are plotting this Me by QE against Me in milligram. Yes, so what I suggest is I'm taking this point directly and the top point directly. So the coordinates of my point I can make out from here is, yes, this one is 0.134. yes, and on the x-axis this is 10, right? So this is 0.13410, and the other point is here, this one, which is 0.011, I can see. And the timings here is, sorry, not the time, the Me is 0 here. So if I note down these coordinates here, let me note down here the coordinates given here. So 0.134 and 10, and then we have 0.011 and 0. These are the two coordinates, and if I find out the gradient or slope, I can write 0.134 minus 0.011 divided by 10 minus 0. So this is how I find the gradient, and I've got the gradient as 0.0123, and the units will be gram per milligram, because the y-axis which I have taken, that is in grams, and the Me is in milligrams. So I can write it as grams per milligrams unit. Here we can again check. Here we have on y-axis grams and the x-axis we have milligrams. So our unit is grams per milligrams. Yes. Okay. Now the adsorption parameter Q0 is a maximum mass of ethanediolic acid adsorbed per gram of the activated carbon. The equation of the line of best fit plotted in figure 1.2 is shown, and here is the equation. Constant, you know, the y-intercept is 0, so we have to ignore constant as 0. Use the gradient determined in H1 to calculate the adsorption parameter Q0. Now if you were unable to given, yes, it's given, but then we were able to calculate. So let's find out what is Q0. If we equate that Q0, then Q0 is equal to, you can say, ME upon ME by QE. That's what we can find out. But our gradient was ME by QE divided by ME. So we can write that is 1 upon gradient here, because that's the reverse of the gradient which we have found out. So if we reverse that, then we have to find out as 1 upon 0.0123. So QE, if we calculate that way, we have 81.30 in 3 significant figures. So that's how we get milligram per gram of Q0 value here, and that's what we are supposed to calculate from the gradient. I hope our calculation is very clear. If we go ahead with the next part, the experiment is repeated and the value of Q0 is calculated to be 78.1 milligram per gram. The total percentage error for the experimental procedure is 6.5%. Fine. The data book value of Q0 is 86.0 milligram per gram of the activated carbon. Use this information to determine whether the error in the repeated experiment could be counted by the experimental errors or is caused by the other factor. Now, how do we find out that? If our experimental procedure the percentage error, if we calculate, is equal to 6.5 or less than 6.5, then it is the experimental procedure error. But if our percentage error is greater than 6.5, then that error may be due to some other factor and not the experimental procedure. So let's find out what is the percentage error in our experiment. So what's the error? Actual value should be 86.0, but our calculated value is 78.1. So what's the difference? How much is the difference? So for that we have to subtract 86.0 minus 78.1. Now what was the reading which we are supposed to use is 86.0. Now multiply by 100. Now this is equal to 9.2%. Now if our error is greater than 6.5, then obviously that is not due to experimental procedure, because the highest percentage error due to experiment is 6.5. So greater than 6.5 is because of some other factor. So we can write as the percentage error is greater than 6.5. So the error is due to other factors. This is how we can explain. So yes, I think question 1 is over here. So we will solve question 2 next time. I hope the whole explanation of question 1 is clear.